They live in the world. Yeah. Drive slow. Okay, here we go. X to the third times x to the fifth is what? X to the eighth. Thank you. So you learn that if you were multiplying two things that have the same base, you add the exponents, correct? Logarithms solve for exponents. So instead of writing this as multiplication, you can write it as the sum of the exponents. So log base a of a plus log base a of b. Okay, as long as they have the same base, you can add them together. And then write it as multiplication. It's a nice little rule. So what do you think we do if we divide? Yep, minus log base a of a minus log base a of b. Oh, the last one. What if you got a power to a power? What do you do? Multiply. So you would take that power and you would multiply it by the exponent. These are the it is a C. Here's a hint. Is there a C in the original expression? Okay. Use laws of logarithms to rewrite the expression in the form with no logarithm of a product, quotient, root, or power. So right now this is written as the log of 5 times 3. I don't want it written as a product. So I'm going to use the first property to write it as log of 5 plus log of 3. These two expressions are equivalent. Sure, because multiplication and addition are commutative, so you can move them around. Yes. The next one, you see you have exponents, okay? I'm going to separate it like this. Log of 3 plus log of 4 squared plus log of 5 to the 6th. Now what should I do after that? Move the exponents out front. Log of 3 plus 2 log of 4 plus 6 log of 5. Now, you might wonder why it works out like that. Let me just show you a little trick here. Log of 4 squared, would you agree that's the same as log of 4 times 4? Would you agree that that's the same as the log of 4 plus the log of 4 by our first property? So how many log of 4s do we have? 2. See how that works out? Pretty cool. Okay. All right. So, last year or the year before, I went to Miss Nelson and I asked her to do a couple of these problems, and just asked her, how she did it when she was in high school and learning the material. And she said, "I don't know how I did it. You just do it. Look at the problem, you do it." And that was the same reaction that I had as well. But there are so many questions from students. By what process do you decide what to do first? This is how you decide. And even though I share this is the process, many people still do not comprehend it. And by far and away, this is the part that people get wrong on the test, okay? So as far as the hardest content, I think that today's lesson is it. You have to consider the order of operations and choose the last operation, and that is the first thing you undo. So in this situation right here, okay, log of 4 over 7 to the 3rd power. Do you first take 4 divided by 7, or do you take 4 to the 3rd, then divide it by 7? What do you do first? 4 divided by 7, then you take it to the 3rd power. So the last thing you did was raise it to a power, correct? Therefore, that is the first thing you will undo. See that? So I will first undo this power. 3 log of 4 over 7. So I don't separate it into subtraction first. The division was before the exponents. Now, 3 log of 4 minus 3 log of 7. Yes. You do, because the 4 is being taken to the third as well as the 7. So therefore, the 3 should be attached to both. Okay. All right. D. What is the exponent in this problem? 1/2. Log base 3 of x squared minus 5 to the 1/2 power. So now what we will do is we will draw that 1/2 out front. The directions say write it with no product, quotient, root, or power. Is this a product? This is a difference, correct? So we have a difference, and you cannot separate that difference. You can't. So I can't get at this x squared. If it was 5 times x squared, that would be different. If it was x squared divided by 5, that would be different. But I can't get at that x squared because of the minus 5. So it's done. Letter E, I think, is a great example. Yes. The what? Right here? Uh, the logarithm of a quotient. So this is a quotient times a logarithm. Okay. E, which operation do I undo first? We'll see if you guys can get this. Which operation do I undo first? What'd you say, Emily? How confident are you of that? Why? Okay, well, look it. If we were to plug in something for x, we would minus 2, then cube it. Up top, we would take the fourth and multiply by 2. And at the very end, we would divide the two results, correct? So therefore, division is the first thing you need to undo. Okay? So again, you got to think about that order of operation. The outer structure of this problem, the outermost structure is the division. So therefore, we have the natural log of 2x to the fourth minus the natural log of x plus x minus 2 to the third. Okay, see how smart you are now. Natural log of 2x to the fourth. Do I take care of the 4 or the 2? Which is it? It is the 2. Why? Look at your order of operations. If you plugged a number in for x, what would be the first thing you would do? Take it to the fourth, then multiply it by 2. So therefore, since the last thing you do is multiply by 2, that's the first thing you'll separate. If it looked like this, natural log of 2x quantity to the fourth, then you would move the 4 out front. But that's not what you have. Yeah. We can, yeah, we'll move 3 out here. But here in this situation, we have to go natural log of 2 plus the natural log of x to the fourth minus the natural log of x minus 2 to the third. Now we'll deal with our exponents. So this is done, but these two are not, are they? So natural log of 2 plus 4 natural log of x minus 3 natural log of x minus 2. Thoughts on F, our last one that we try, and then we move to something different. Cubed root, thank you. This is the natural log of 4x squared over 2yz to the 1/3 power. So as I think of it like that, what is the first thing you need to undo? The 1/3, because everything is being taken to the 1/3. That's the outermost structure of it. So 1/3 natural log of 4x squared over 2yz. Now let's look at this inside piece. What part do we undo now? The what? Division. Yes, I undo the division. Thank you.